So I recently saw a documentary and also heard from another friend on Facebook about this image that you are seeing, not this particular image, but the art of balancing stones. And there are these people who do this more or less as an art form. I suppose it's a very old thing. You travel in the Himalayas and you often see in many places where you come down to the valley close to the river that is flowing, that there will be these small stones which have been piled one upon the other. Sometimes quite a lot of them, but nothing remarkable about it. Larger stones, and then as you go higher and higher, smaller and smaller stones. But then I came across these people who actually take it to a kind of a meditative form of art, whereby they just look for stones that are there in the river and or in a stream bed, and they arrange these stones so that they are balanced in some incredible manner. And I didn't believe it at the beginning. I thought, they must be using some kind of a trick, some kind of a glue or something like that to hold these stones together. But then I saw a documentary in which I saw that the person actually built one such thing, and the different sort of challenges that occur as a as a result of attempting something like this. So these stones are actually balanced on top of one another, as incredible as it may seem. And pretty soon after they do this, or sometimes in a day or so, because of natural reasons, some imbalances that occur, the whole thing collapses. So the video in which I saw this, he made such a sculpture, if you can call it that, and he left a camera there to record whatever happened to it. And after a few hours, of course, the whole thing collapsed, and that was also caught in camera, proving to me that it was something that was actually balancing the way he set it up. So how does one achieve something like this? How can we understand it from a physics perspective? Okay, so the thing is that each one of these stones obviously is being balanced in such a way that the center of gravity, that means the line of action of the force of gravity, is perfectly countered backwards by the the normal reaction force given by the stone below, etc., etc., going all the way down to the ground below. So how does that work? So you remember the topmost stone. Okay, so the topmost stone, I'm just going to make a sketch of the top two stones and try to illustrate in what way our understanding of center of gravity can give us an understanding of how this happens. Okay, I'm just copying down the whole thing as best as I could. And then I'm going back to my screen. So, I mean, it doesn't look anything like that, but imagine that that is what is happening. So this larger stone is being balanced by the smaller stone, and therefore we can say that sigma f is equal to 0, which means that the CG of the stone acting downwards and the normal reaction force provided by the smaller stone are in line with each other. So to examine this situation, we can take, that is, we are looking at it from the principle of moments. So assume a number of tiny mass elements, okay, very, very, very small mass elements. Take one over here, let's call it M1. Take another one in random somewhere else, call it M2. Take another one M3, another one M4, another one M5, and etc., all the way to Mx. Okay, it kind of came around in a circle just to break the sort of symmetry. I'm going to put one over here and one over here. Okay, so a number of such mass elements where each one of these mass elements m1 to mx is way lesser than the mass of the stone. All right, now each one of those mass elements is going to be pulled down by gravity because it's acting, its whole thing is happening in the field of gravity. So therefore, the mass elements are going to be pulled down. So the mass element M1 is going to be pulled down in that way. M2 is going to be pulled down in this way. M3, I didn't put an M3. Wow. Oh, this is M3. This is M2. M4, M5, M6, M7, and MX. In other words, all of them are being pulled downwards. Okay, and if you lift the stone up and you drop it, the whole stone will fall exactly in the same way. But this is not such a case. So what is happening over here is there is an axis through which the stone would tend to rotate. Okay, so let us just look at it two-dimensionally. Of course, the whole thing happens in 3 dimensions, but let us just examine for 2 dimensions. In 2 dimensions, there are 2 possibilities. One is the stone rotating in the clockwise direction, and the other one is the stone rotating in the anti-clockwise direction. Of course, if any of those 2 things happen, then the stone would collapse this way or that way, destroying the sculpture as it will. Now, since sigma f is equal to 0, right, then we have to say that clockwise moments and anti-clockwise moments are equal. So we have to say this is clockwise and this is anti-clockwise. So let me put it like this. Anti-clockwise moments should be equal to clockwise moments. Okay. Now we don't know where the center of gravity of this stone actually is. So what we can say is that if you take the line, let me draw this. If we draw a line which is perpendicular to the ground, okay, then we can say that the center of gravity has to lie somewhere along there because of our initial condition. We said that sigma f is equal to 0. That means the mass of the stone, the weight of the stone, acting downwards, and the normal reaction force are acting in this way. So therefore, the center of the axis of rotation has to lie somewhere along that line. Are you clear about this point?
So the anti-clockwise and clockwise movements have to be equal because of sigma f equals 0, right?
Correct. Yes, it follows from this. I can say since and change the arrow sign. Okay, are you okay with this argument that there is this a line? At the moment, you can take it as lying on this plane, but it can be a kind of a plane going right through the stone. The center of gravity has got to lie somewhere along this line. Maybe higher, maybe lower, we don't know, but it lies there. Is it clear, that part? Because that's very central to our argument. Okay, I'm assuming that you're all agreeing. Now, how should I show this? Let's look at the anti-clockwise moments. Okay, and I'm taking this mass element M4, if you can see it. I'm just going to expand that a little bit over here to illustrate my point. So the line along which the CG lies is represented by that blue line, and the mass element M4 is there, and the gravitational pull of it is along here, G. Happy with that? Now, the torque that is created by that force, M4 times G, okay, will be M4 times G times the perpendicular distance to the axis of rotation. Correct? Agree with that? Not following? Ask me.
But wait, the line that you said when CG has to lie on.
Yeah,
So couldn't why? I mean,
it's
it
not a
could be
line,
some.
it's a plane. It's not a line three-dimensionally, it's a plane. But
Okay, fine.
two-dimensionally, we can say that it lies somewhere there. Correct? Agreed?
Kinda. I mean, I'm not.
Okay. So let me proceed then. Multiplied by the perpendicular distance from the line of action of force to the center of gravity. Right? This part is the most important part. But right now I have just written a statement. Okay? Now that length is this length. Length of M4. Is that part clear? If it's not clear, ask a question. Move on. Okay. Okay, Darshan. Anyway, I'm recording the class, so I'll post it. And just to tell to everybody else also, I'm recording the class. I'll put it on my YouTube and channel, and I'll post the link in the stream. You need to follow these arguments a little bit closely to be able to get it. Okay, so if you don't want to ask anything at this point of time, it's all right. I'll continue. I realize the time is gone over the usual time, but just please hold on for another 2-3 minutes. We'll stop at 1-2. So if you agree that the torque that is caused by M4 is going to be pulling it in this direction, as it is obvious because of the location, the torque is equal to M4 multiplied by G multiplied by the length from the line of action of the force to the axis of rotation. That has got to be this length over here. Then we can say that all of these masses which are going to create the anti-clockwise moments fall under the same category. Okay, so it will be M4. I'm going to leave out G because G is going to be common on both sides of the equation. So I'm just going to eliminate G. I'm just going to keep M4 multiplied by the length of M4 plus M5, what I have written down, times length of M5 plus etc mx times length of mx. So this is all the left hand side, the anti-clockwise moments. And I can say the same thing for the right hand side. M1 times length of M1 plus M2 times length of M2. Wait, somebody's wanting to get in. And I dropped my pen. Got it? And then M3 times length of M3, etc., etc. adding everything that is causing the clockwise moments. Now we can say that the center of gravity of this object is a point in such a way that all the anti-clockwise moments and all the clockwise moments caused by all the mass elements on this object cancel to zero. Do you get it? So let me repeat that statement. The center of mass is such a point on this object such that the anti-clockwise moments of all the elements that are causing the anti-clockwise turn and the clockwise moments that are causing the clockwise moments, when you add the two, it will become zero. So that is the rigorous definition of what the center of gravity for an object is. And of course, you can say that, okay, but that's because you're looking at the object in one particular direction. What if you turn the object? Well, if you turn the object, exactly the same arguments will hold. If you turn the object this way, exactly the same arguments will hold. So you can therefore say that in 3 dimensions, if you take all the mass elements that constitutes an object and you find out that the clockwise torques and the anti-clockwise torques that are produced by these points, if they are equal, in other words, if you add them up, it becomes zero, the torque becomes zero, then such a point is the point which is known as the center of gravity. Any questions about this?